Okay guys, so in the last video we spoke about how you can take notes and gave you some tips and advice on how to do them. So I thought in today's video I'm going to get some notes for you and we're actually going to do a live note-taking demonstration. So from here, as you can see, I've got some A-level physics. So a lot of you may not be doing A-level physics, but that's totally fine. The notes that I chose for today have an equal kind of spacing of definitions, equations and some diagrams. So this should be able to apply to pretty much any A-level you're doing. And I'm just going to show you my process of doing it. So these are just from Physics and Maths Tutor, so I'll leave the link to these notes in the description just so you can get to them. But let's get started. So we'll just do a couple of pages of this. So first things first, we're going to write the title. So the title for this one, as you can see, is particles. So I'll just literally write particles and radiation. So your handwriting doesn't actually need to be particularly neat with this. All that matters is you get down the proper information and you kind of colour code it properly. And for the first part, it's literally just particles. So using subheadings and things like that are really good, make them stand out by underlining them, capitalising them, etc. You can even write them in different colours if you have another colour. So as you can see on the right, I just have 4 different colours. I also have blue, and also have a pencil and a ruler. That's all you really need. If you're using a tablet, then you basically have an infinite number of colours. And let's just start reading through it. So the first part says kind of the constituents of an atom. An atom is formed of 3 constituents: protons, neutrons and electrons. So that will be the first thing I write. Okay, so atoms made of protons, neutrons and electrons. Also, feel free to watch this either on speed 2 or maybe even skip through it so you can just see the process afterwards. And that'll be the first thing. Now, the rest of this information, so they're known as nucleons, so we can even write that down as well. So nucleons, found in nucleus. So this would be protons and neutrons. So as you can see, that first paragraph, I've basically written it in 2 small sentences. So just take up the key information. Now this is where knowing your spec is actually going to come in really, really handy. Because if you know your spec, you know exactly what you can be tested on. So I would actually have, while I'm making my notes for the first time, a printed specification, and I can just have a look at the bullet points, because it's a bullet pointed list, exactly what they want me to know. So for that, that's all we actually need. Now this table here, this is actually, a lot of this is from GCSE Science, so most of you are probably already going to know this anyway. But there is a new equation here, specific charge. Now for specific charge, since it's an equation, I like to use a different colour. So for this I'm just going to use, let's say, purple. And all I do is I write out specific charge and that is just equal to the charge of the particle divided by its mass. And the reason why we're using a different colour is that this stands out. So if I'm looking at my particles and radiation notes, chances are I'm actually going to be looking for an equation. So I can quickly see exactly where the equation is. And the next part that we have are the units. So it tells you the units slightly further down. So here it says coulombs per kilogram. So I'm just going to write here, for units in maths and physics and science and things, I actually put the units in square brackets just to make it super clear. So that is exactly what I'll do, and the rest of this is kind of obvious. So here it says the specific charge is the charge to mass ratio. So you can kind of ask yourself whether or not you want to write that down. Now for me personally, I know that if you divide one number by another, you can always say that that's a ratio, or it's a division, or it's a charge per unit mass. I know that instinctively, so I don't need to write it. There's no reason why you don't have to write it. Remember, these notes are for you. So other than that, I think this is pretty much everything else we need, but there is another important thing here. We have this. It's a type of notation. So in chemistry and physics, instead of writing out, for example, carbon, and then we say exactly how many protons and neutrons it has, instead we use this. We use chemical symbols. So what we're going to do here is we're going to write that out, and since it's something different, I'm actually going to write out in green. It's a notation. So I personally write notations in green. So far, purple for calculations, like equations, like this cyan colour for units, and I'm going to use green if it's a notation. So it doesn't come up that often. But we're going to have X and A Z, and then what we're going to do is define exactly what they are. Now, since it's just words, I'm going to write it in black. So Z is just the proton / atomic number. So this is unique for every single element. And then we have the mass number, or the nucleon number. And that's unique for every single isotope. So again, I've summed up basically the whole first page of notes, and I've summed it up in maybe a third of a page. Okay, so that's kind of the power of note-taking. And this is all of the important information. So again, let's say this example here. You can use it if you want. So if maths isn't your strong suit, or you kind of don't understand a calculation, have an example, and I would write those out in blue. I'd write example 1, and I would have basically exactly what it says on the screen at the moment, and that would help me out. But again, for me, I think that's totally fine. Just take the charge divided by the mass, that's totally fine. Okay, and the next thing we have is another definition. However, this definition is a bit special. So isotopes are atoms with the same number of protons but a different number of neutrons. So again, if you're not doing A-level physics, or you're not planning on doing it, that's totally fine. Essentially, all I'm doing here is I'm taking notes in roughly the same way you'd expect. So we have like definitions, we've had calculations, we have notation, we're going to have some diagrams as well. So just take the bits that you are used to. So you should be looking at this and seeing why I'm making the decisions I am and how I can apply it. So it can apply to any subject. So since this is a definition, I like to write definitions in something that sticks out. So this is actually an exam definition. So again, this is where knowing your specification helps. This up here, atoms made of protons, neutrons, electrons, nucleons are this proton and mass number. I know that this isn't an exam question. They'll never ask me what Z is. They won't ask me what atoms are made of. But I know that they will ask me, or they can ask me more likely, that what an isotope is. So again, knowing your specification and having that out in front of you in lessons and whenever you're doing questions and notes, etc. is extremely important. So simply just write out the definition. Isotopes are atoms with the same number of protons but a different number of neutrons. Okay, so what I'm extracting here is as many marks as possible. This is an answer to a 1 mark exam question. So there you go, I've got 1 mark right here. And I've also got some marks for the specific charge when that comes up. So if you have a look at the rest of it, this is done through carbon dating, etc. This is just an example of an isotope. But if I understand what an isotope is, maybe from GCSE or just from my own knowledge, I don't need to write it down. So that's another paragraph we don't need. So now we're looking at stable and unstable nuclei. You can write a little subheading if you'd like. Let's just do it to be super neat. So stable. I promise I'm not going through all of these notes, by the way. It'll only be a short session, so I'm not going to go through all of these. So stable and unstable. Whoops. Nuclei. So again, I'm writing a bit quickly, that's why my handwriting isn't the best. And the next thing it says, the strong nuclear force keeps nuclei stable by counteracting electromagnetics. So that'll probably be the next thing I write. So, and this is where you can kind of have a creative choice. Here, they define the strong nuclear force first, and then they draw the diagram. But personally, I'd actually draw the graph first. Okay, so let's do that. So again, ruler and pencil. Always draw diagrams in pencil. You can go over them in pen afterwards. But I do them really lightly in pencil, and then if I want to go over them in pen, I can trace it out. Keep in mind, if you have a pen, you can't actually erase it. And Tipp-Ex is really ugly for notes, and it can ruin the paper. Now, of course, if you're using a tablet, this isn't a problem at all. So let's draw this graph out. Again, use a ruler. That's neat. I'm not going to go over this in pen, but like I said, you're more than welcome to. And then we want to stick it out a little bit. And then we draw our little arrows. And then actually we don't need one there. And all we need to do now is take out the important information. Okay? So if we look at the important information here, it's a graph. So what's important about a graph? Well, these numbers on the side that they have are important. The actual overall shape of the graph is important, as well as kind of this bit on the side where it says repulsive and attractive. So let's draw the shape first. So again, it doesn't need to be perfect. Right. Something like that. And that's okay, the overall shape's good. And what are these things on the side? So what are the axes names? We have separation of nucleons in femtometers. So separation of nucleons in femtometers, and along this axis it's the force between nucleons in, so I might write this in the margin. And that's in times 10 to the minus 4 newtons. Cool. And now we actually want to add the values that we have. So first off, this is obviously the origin is 0. This here is 0.5. I'm just getting this from the notes, by the way. Don't worry about understanding this, because if you're not doing physics, it really doesn't matter to you. And this down here says attractive. Again, I will actually have videos on A-level physics, so I will explain this graph at some point on the channel, but that'll come a bit later. And up here it is +3, and here it's repulsive. And since that's a different colour, I'm actually going to use a different colour as well. So repulsive, okay? And again, that just helps it stand up from the axis title as well, right? Because I'm not writing it all in black. So keep in mind, your brain actually picks out, or your eyes, whatever you want to call it, will pick out different colours very easily. Like the things drawing my eyes at the moment is this pink thing here, which I said was an exam question, so it's good that my brain is picking that out. And then the calculation, which is important too. And then this repulsive thing, and right underneath I've got attractive. That's the important part of the graph. Okay? So again, I didn't spend super long on it. You're not Vincent van Gogh or anything. Don't make it super... You don't have to make it super pretty. Some people actually like it when their things look pretty. So it motivates them to do the notes more. That's totally fine. Makes it easier to look at too. So if you want to do that, that's totally fine, but it's not necessary. And okay, so now let's finish off the notes for the strong nuclear force. So what exactly is it? So it says here that it keeps nuclei stable by counteracting the electromagnetic force of repulsion. Okay, cool. So what does this mean to me? So keep in mind that I'm not mindlessly copying out the notes. If you look at my notes compared to the notes on the screen, they aren't the same. The wording is different, because what I'm doing is I'm taking in the information and then I'm explaining it in my own words. Now, of course, the wording is similar because it's the same idea, but it shouldn't be the same. Okay? So strong nuclear force keeps nuclei stable. So what does it do? Well, it holds nuclei together. The strong nuclear force, and again, these are just words. This isn't an exam question. So the strong nuclear force holds atomic nuclei together. And one other thing you should note is that when you do note-taking, it doesn't mean that you just make it smaller. That's not what it always means. If you want to copy an exact passage, you're more than happy to do it. Or you may find a definition, but you don't think it's enough. So instead of a one-sentence definition, you actually have a two-sentence one that's still note-taking. It doesn't have to be shorter. It's just writing things in your own words that you can use to study from. And then, how does it do that? So how does it hold them together? Oh, actually, no, I need to finish the word together. By opposing electrostatic force between protons. And again, they wrote that it's repulsion. But I know that because they're the same charge, they're going to be pushing each other apart, and that's fine. So now there's something in the notes that I've got on the screen that's going to be in my notes on paper. And what's that? Well, they've given me a graph. Great. What does the graph mean? Explaining this kind of graph is an exam question, or it can be, but let's say it's not. Assume it wasn't. I need to understand this graph. How can I test my understanding? Well, what I'm going to do is say what this graph shows. Okay? Because if I can say what this graph shows, then I understand the concepts. Now, whenever you're drawing a graph, you need to understand it, or a diagram, any kind of diagram. Again, this works for things like geography and history and everything. When you're looking at a table, a graph, a picture, whatever, you should explain to yourself what's going on and does it make sense. because that's how you know you understand the concept, okay? So in this question, what's going on here? Well, over here it says that when it's below this line, it's attractive. So between 0.5 and 3, it's attractive. So let's write this out. So 0.5 to 3 FM, it's attractive. And I also might want to write what a femtometer is. A femtometer is a million billionth of a meter. Okay? And what about below this? Well, below 0.5 FM, it's repulsive. Whoops. And this is where you might ask the question, well, why is it repulsive? Why does it go from repulsive to attractive? Again, if you're not doing science, that's totally fine. But all it's to stop is to stop from nucleons overlapping each other. So that might be a question. I write in the margin in blue and say, well, I'm going to ask my teacher, why is it repulsive? Okay, so I might literally do that. So right. And that little note there means the next time I look at these, I'm going to now go to my physics teacher and say, why does it go from repulsive to attractive? I don't understand that. And they can explain it to you. In this case, it just means, because I already know the answer, again, you can, with this question here, you can Google it, ask your teacher, ask your tutors, whatever, but I already know the answer. It prevents nucleons overlapping. And the reason for that is the radius of a nucleon is about half a femtometer. Cool, and what's the last thing I can tell? Well, it goes to 0 at 3 FM, so it's short range. And you can just say approximately 3 femtometers. Okay, so that is everything this graph tells me in words. Okay, so now we need to change over, go to the next page. So let's do that. Now let's make sure it's in frame still. A bit lower. There we are. And I'm just going to do a little bit more. And if you look here, it says unstable nuclei are those who have too many protons, neutrons, or both, causing the strong nuclear force not to be enough to keep them stable. Cool. So I'm just going to write unstable nuclei. Too many protons, neutrons, or both. Slash neutrons. Slash both. So then I might say some definitions. Again, this is not an exam question, so it's just in black. This is just for my own understanding. So strong nuclear force, which they call SNF, too weak to hold nuclei together. To hold nuclei together. And another thing is that it means it's going to decay. So the last thing I'll do is I'll talk about these two types of decays in my notes, and then I'm going to stop. Okay, so we have essentially an equation, right? It's kind of like an equation here. It looks very complicated, but it's actually not that bad. So let's talk about alpha decay. Again, we're not going to go too much in the physics of this because a lot of you aren't going to be doing physics, that's totally fine. But hopefully you can see how I lay out different sets of notes. So alpha decay, this is normally large nuclei, and again I'm basically rewriting what's here. So it says it occurs in large nuclei with too many of both protons and neutrons. So large nuclei, too many protons and neutrons. Okay, so I'm basically just rewriting what it says, but in my own kind of way. And then, because it's like a notation, right? Remember what colour notation was? It's green. So let's use green. So we have A, as soon as the pen starts to work, AZX goes to A minus 4 because it loses 4 of its atomic number, Z minus 2 because it loses 2 protons, and that's going to be Y plus alpha particle Cool. And then I'm going to write what actually happens. So what happens? Well, proton number decrease by 2, mass number decrease by 4. And that's it. That basically tells me everything that is said on here, right? So that's all good. Now if you notice, I actually rewrote this exactly. The reason why is because when I looked at it on the screen, I thought actually that's a good way to represent the information, so I'm going to copy it. And honestly, there's not really many ways to reword this that aren't just semantic differences. What I mean by that is don't feel forced to rewrite everything in a different way. If it's just one sentence and it's very basic, don't get out your thesaurus and start looking up synonyms just to make it different. Rewrite it, assuming that you would explain it in a different way, which honestly for most things you'll write them in a different way. But in this case, honestly, there's not really many other ways to write that, so I'm going to leave it like that. And lastly but not least, we have beta minus decay. And if you look on the screen, a lot of words, nuclei which are neutron rich, have too many neutrons, so all I need to write really is neutron rich. You don't need to write in full sentences, write in a way that makes sense to you, because you're the one that's going to be benefiting from these, by the way. Unless you're also going to sell these online, so you might want to think about that too. But if it makes sense to you, I guarantee you it makes sense to at least one other person on the planet. And that goes along, and we have A, and the proton number increases by 1, Y, and then we have 0, minus 1, beta particle, plus an anti-electron neutrino. That might have been a bunch of words that you're not too sure about. Again, don't worry, this is just an example. So proton number here, what happens to it? It increases by 1. And the mass slash neutron number same. So if you have a look, we've done the first 3 pages of notes. Actually, not even that. We've done 2 pages of notes, and we've done it in a page and a half. So you might think, well, that's not very much, right? But basically, I'm only taking up 75% of the space. So if you had 100 pages of notes that you're meant to record, you'll only need to write down 75 pages. But again, it's not about rewriting it in a short way. It's about rewriting it in a way that makes sense to you. Because what this has forced me to do is read what's on the screen, understand what's on the screen, and then write it in my own way. So I'm learning this. If you literally just copy out everything that's on the screen now, you won't understand it, which means you won't remember it. You may as well be reading something in French and just writing out French without understanding it, right? You need to understand what you're doing. If you don't understand, you may as well be writing in a different language for all the good it's going to do you. So, I hope you found that really useful, or at least somewhat useful, and it gives you some ideas on kind of what I mean by using colours and using rulers and pencils and stuff. And hopefully you can kind of see where it's going. Again, if you're not doing physics, don't worry. Hopefully you can see that a lot of this is applicable to other kind of disciplines. And I hope that you have a truly wonderful day.